Dear students, I am M. Sermarajan, MSc B.Ed MPhil, Department of Chemistry. In this video, I am going to explain about lesson number 12, carbonyl compounds and carboxylic acid. Topic number 1, functional derivatives of carboxylic acid. Functional derivatives of carboxylic acid. Compounds such as acid chlorides, amide, ester are called carboxylic acid derivatives because they are differ from carboxylic acid only in the nature of the group or atom that has replaced the OH group. It's very simple, students. Instead of the OH group, this is the formula for acetic acid. The acetic acid formula is CS3COH. Here, instead of OH, if you substitute Cl, the formula will become as CH3COCl. That is nothing but acetyl chloride. See the first formula and the second one. First formula we have CH3C double bond OH. This is acetic acid. Instead of OH, if I substitute Cl, it is called as acetyl chloride, and this acetyl chloride belongs to acid chloride. Second one, instead of the same OH, if I substitute NH2, the compound will become CH3CONH2. The particular compound is called as acetamide. The general formula for acetamide is acid amide. Similarly, instead of OH group of acetic acid, if I substitute OR, that is alkoxy group, then the compound will be as CH3C double bond O bond OCH3. This is nothing but methyl acetate. Methyl acetate is nothing but it belongs to ester group. Similarly, the last one, instead of OH group of acetic acid, if I substitute RCOO minus, the formula will become as CH3C double bond O bond OCOR. Finally, we will be having, first part we have CH3C double bond O, finally we have RCOO group. This is an example for acetic anhydride and it belongs to the group called acid anhydride. So in all the four example, instead of OH group, basically they are from acetic acid. All the four, acetyl chloride, acetamide, methyl acetate, acetic anhydride, they are obtained from acetic acid. They are the derivatives of acetic acid. Why they are called as derivatives? Because they are all prepared, they are all obtained from the compound called acetic acid. Instead of OH, if I substitute Cl, we will be getting acetyl chloride. Instead of OH, if I substitute NH2, I will be getting acetamide. Instead of OH, if I substitute alkoxy group, I will be getting methyl acetate. Instead of OH, if I substitute RCOO group, I will be getting acetic anhydride. So since the OH is replaced by different group, they are called as derivatives of acetic acid or derivatives of carboxylic acid. Next here we are going to discuss about the relative reactivity of acid derivatives. So far we have discussed 4 acid derivatives. The first one is acid chloride, acid anhydride, ester, and the fourth one is amide. Among the 4, which is having more reactivity? Among the 4 acid derivative, acid halide is more reactive than ester, acid anhydride, which is having more reactivity than ester, and the acid amide is having least reactivity. How the reactivity is calculated? The reactivity is calculated by 2 different terms. One is basicity of the leaving group and the second one is resonance effect. By these 2 concepts only, we have classified the acid derivatives reactivity into the above mentioned form. So here, how they are classified means, see the next reading. First one, basicity of the leaving group. Here, which is the leaving group? See here, this is the acid chloride, acid anhydride, ester, amide. Among the 4, which is the leaving group? See in all the 4 example, first what we are having RCO. That is a common. What about the remaining except RCO, which is here? What is here? We have Cl. Except RCO, here we have OCOR. Except RCO group, here we have OR. Except RCO, here we have NH2. So these are the leaving groups. Whatever I have encircled here, that comes under the leaving group. That leaving group, based on the leaving group, the reactivity is determined. Look at the first point. Weak bases are good leaving group. Among the 4 leaving group, which among the all are basic leaving groups? Among the 4 basic leaving group, the weak basic leaving group will be the good leaving group. So which is the weak basic leaving group? Come to the 4th point. The correct order of basicity of the leaving group is Cl minus is least basic than RCOO minus, which is least basic than OR minus, and which is least basic than NH2. So among the four, the most powerful leaving group is NH2, and the most least leaving group, that is the most weak leaving group, is Cl minus. So weak bases are good leaving group. First point says the weak bases are good leaving group. Among the four basic, which is the weak base? Cl minus is the very weak base. So it will be the good leaving group. So the derivative having the weak leaving group, the derivative having this good leaving group will be the more reactive. சொல்ற புரியுதாப்பா? இந்த Cl minusங்கிறது இங்கே வந்து good leaving group. First point, what does the first point says? Weak bases are good leaving group. So here among the four, Cl minus is the weak base. So Cl minus is the good leaving group. So the compound that contains Cl minus, what does it happen? The Cl minus will get eliminated easily, so it will become more reactive. That is what the fourth point says. RCOCl is having more reactivity. Next to Cl minus, which is the good leaving group? RCOO minus is the good leaving group. That RCOO is present in acid anhydride. Here is the acid anhydride. It contains RCOO group. So that is the next reactive as functional derivatives of carboxylic acid. After RCOO minus, we have OR, that is RO, alkoxy group. That alkoxy group is found in the RCOOR. So it comes under the third reactive functional derivatives of carboxylic acid. Among the four leaving group, the NH2 is the most powerful leaving group. Okay, so it cannot be removed easily from the RCONH2, so it is eliminated very slowly. So it acts as a least reactive functional derivatives of carboxylic acid. Okay, so this is based on the leaving group. I have classified the reactivity of the functional derivatives of carboxylic acid. The next one is resonance effect. Look at this expression, RC double bond O bond G. Here G represents the leaving group. Okay, it get transformed into another form just by delocalization of electron. The leaving group has a lone pair of electron G. Upon the G I have marked a lone pair of electron, that is nothing but the leaving group containing lone pair of electron is shifted to make a double bond. As a result, the carbon oxygen double bond will become a single bond and CO minus is obtained. So this is nothing but a kind of tautomerism. Here, the lesser the electronegativity of the group, greater will be the resonance stabilization. ஓகே, அப்போ அந்த லீவிங் குரூப்போடைய எலக்ட்ரோநெகட்டிவிட்டி கம்மியாக இருந்தால் அந்த மாலிகுலோடைய ரெசனன்ஸ் ஸ்டெபிலைசேஷன் வில் பி கிரேட்டர். ஓகே, ஸோ அமங் த ஃபோர், கம் டு த தேர்ட் பாயிண்ட், four groups. Which group has the least electronegativity? Cl minus is having great electronegativity than RCOO minus, which is having greater electronegativity than RO minus, and which is having greater electronegativity than NH2. So among the four, the NH2 is having lesser electronegativity. So if the compound is having less electronegative group, greater would be the resonance stabilization, right? Greater would be the resonance stabilization. Appa resonance stabilization means and the compound almost it becomes stable. Appa stable and the reactivity will get decreased. So that is what look at the fourth point. Among the four order, the last one, which is nothing but acid amide. Acid amide means the compound that contain NH2 group falls as the least reactive acid derivatives of carboxylic acid because it contains NH2 group. The electronegativity of the NH2 group is very, very lesser, so its reactivity also very, very less. Similarly, come to the first one there, Cl minus. Cl minus is having more electronegativity. More electronegativity means the resonance stabilization will be lesser. Appa resonance stabilization stability kammiya irukumbodhu reactivity will be higher. So the acid halide stands as the first in reactivity among the acid derivatives of carboxylic acid. So this is the method by which the various acid derivatives are classified into their reactivity. Thank you.